Hello viewers, I Nilofer welcomes you to the second part of the chapter Measure of Central Tendency. In this session we'll study the meaning of 2 out of the 3 measures of central tendency, namely median and mode, and their objectives and their types are also included in the script. Also, before proceeding to study the various kinds of positional averages in the script such as quartiles, percentiles, deciles and etc., we will first acquaint ourselves with the terms which are going to be used in the discussion. So let's start with the brief definitions and introduction. The median by definition is the middle value of the distribution. Whenever the median is given as a measure, 1/2 of the item in the distribution have a value the size of the median value or smaller, and 1/2 have a value of the size of the median value or larger. In other words, the median of a data set is the middle number when the measurements are arranged in ascending or descending order. It is a positional measure of a data set. If the data set is prescribed by a relative frequency distribution, the median is a point which will lie in the mid of the distribution. We'll consider the graph 1.1. The median is a point on the x-axis such that half the area under the frequency curve lies above the median and half lies below, as shown in the graph 1.1. As distinct from the arithmetic average or mean, which is calculated from the value of every item in the series, the median is what is called a positional average. The term position refers to the place of a value in a series. The place of the median in a series is such that an equal number of items lie on either side of it. For example, if the wage of 4 persons is rupees 2,700, 2,720, 2,750 and 2,760, then the median wage would be rupees 2,750. Changing any one or both of the first 2 values with any other numbers with the value of 2,750 or less, and on changing of the last 2 values to any other values with the values of 2,760 and more, would not affect the values of the median, which would remain 2,750. The steps involved are: first one, arrange the data in ascending and descending order of magnitude. Second, if n is odd, the median is the middle number. Third point, if n is even, the median is the average mean of the middle 2 numbers. It can be represented symbolically as median equals to x bar, which is equal to size of n plus 1 by 2th item. X bar is equal to median, n is equal to measurements from smallest to largest. We'll see an example. The first example comes here. Calculate the median from the following data of 7 sample measurements. So 7 samples are given as 4391, 5384, 5407, 6672, 6522, 6777, 6735. Now we have to find the median here. Let's see the solution. Firstly, arrange the given data in ascending order. So we have the given data in ascending order first. 4,391, 5,384, 5,407, 6,522, 6,672, 6,735 and 6,777. Now the data is arranged in the ascending order. The median will be x bar. So that is equal to size of n plus 1 by 2th item. So that is equal to 7 plus 1 by 2. That is equal to 4th item. So size of the 4th item in the data is 6,522. Hence the median value will be rupees 6,522. It means that the 3 samples had less than 6,522 and 3 samples had more than 6,522. The steps involved are: the first one, arrange the items in ascending or descending order of their magnitude first. Second, compute the cumulative frequencies. Third point, apply the formula, which is median equals to x bar, which is equal to size of n plus 1 by 2th item. Fourth step will be, now look at the cumulative frequency, that is CF column, and find that total, which is either equal to f times n plus 1 by 2th or next higher than that, and determine the value of the variable corresponding to this. That gives the value of the median. So for this, again we will see an example. The following table shows computation required to calculate median. So we have a table with us which has a column of incomes given in rupees and the number of persons. Let's see the solution. We have the calculation of median. So for that, we are making again a new table, and table will be of number of families, income, and the third column will be cumulative frequency. So we'll apply the formula, that is median equals to x bar, which is equal to size of n plus 1 by 2th item. So this is equal to 122 plus 1 divided by 2, so that is giving us 61.5th item. That item will be giving us the value of the median. So size of 61.5th item will be 6,580. Hence median income will be rupees 6,580. So the steps involved here will be: the first one, determine the particular class in which the value of median lies. Use n by 2 as a rank of the median and not n plus 1 by 2, because in continuous series it is n by 2 which divides the area of the curve into two equal parts. Second part, apply the following formula of interpolation for determining the exact value of median. So we'll apply this formula, and the formula is median equals to x bar, which is equal to L plus n by 2 minus CF. The whole thing is divided by F times C, where capital L is a lower limit of the median class, CF is a cumulative frequency, is a sum of the frequencies of all the classes lower than the median class, and small f is a frequency, and small c is the class interval. Third example, find the median wage of the following frequency distribution. So we have this following frequency distribution, which has table of wages given in rupees and the number of workers. So we'll see the calculation for this, for the median. So for the median, we make a table of wages, number of workers, and cumulative frequency again. We will apply the formula, that is median equals to x bar, that is equal to size of n by 2th item. So that is equal to 98 by 2, which is equal to 49th item. So median lies in the class 200 to 250. Now this is the median class. So we'll apply the formula now. Median equals to x bar equals to L plus n by 2 minus CF, the whole thing divided by F times C, which is equal to 200 plus 49 minus 40 divided by 30 times 50, where 50 is a class size. That is equal to 215. Hence the median wage will be rupees 250. We'll see another example. Example number 4. Find the median from the following data given below in the table. So again we have a table which contains intervals and frequency. We'll see again the solution to this. We'll make a table of intervals, frequency, and cumulative frequency. Now after making the table, we have calculated the value for n. We know where the median class is going to lie. So we'll apply the formula, that is median equals to x bar equals to size of the n by 2th item. So that is equal to 390 by 2. That is giving us 195th item. Alright. So median lies in the class 150 to 160. So this is the median class. We'll apply the formula to this median class. Median equals to x bar, which is equal to L plus n by 2 minus CF divided by F times C. So that is equal to 150 plus 195 minus 151 divided by 116 times 10. 10 is a class size, which is giving us, after the whole calculation, we have the figure as 153.79. Hence the median is equal to rupees 153.79. Now we'll see the next example, that is example number 5. An incomplete distribution is given below. So this is a table which contains incomplete information. It's a table of interval and frequency. So you are told that median value is 46. So median we already know that is 46. Now we have the first bit of the question that says using the median formula fill up the missing frequencies, and the second part of the question says calculate the arithmetic mean of the completed table then. So we'll see the solution. We'll see for the first part first. Let the frequency of the class 30 to 40 be F1 and that of class 50 to 60 be F2. So these are the missing frequencies and we are denoting it by F1 and F2. The total frequency is, we know, that is 229. The frequencies of classes other than the missing ones are 12 plus 30 plus 65 plus 25 plus 18, so that is equal to 150. But we know that F1 plus F2 is equal to 229 minus 150, so that is equal to 79. Now the value of the median is also given by the formula median equals to x bar, which is equal to L plus n by 2 minus CF divided by F times C. So we'll apply this formula. Median is equal to x bar, that is equal to size of n by 2th item. So this is equal to 229 divided by 2. So that is 114.5th item. Median class is 40 to 50. Now let's apply the formula, and after applying the formula we are having 46 equals to 40 plus 114.5 minus 12 plus 30 plus F1, the whole thing divided by 65 into 10. So that implies 46 is equal to 40 plus 114.5 minus 42 minus F1, the whole thing divided by 65 into 10. So that implies 46 equals to 40 plus 72.5 minus F1 divided by 65 into 10. Then that is 40 goes to the other side, it becomes like 46 minus 40. And on the right hand side we have 72.5 minus F1 divided by 65 into 10. Then again on left side we have 0.6 equals to 72.5 minus F1 divided by 65. Then we have 39 on the left hand side, and on the right hand side we'll be having 72.5 minus F1. So that implies that F1 is equal to 72.5 minus 39, that is giving us 33.5 or 34. Since F1 plus F2 is equal to 79, so F2 will be, now since we know the value of F1, we are substituting the value of F1 here. So F2 equals to 79 minus 34, which is equal to 45. So F1 is 34 and F2 is 45. So first part of the question has been solved. Now let's come to the second part of this question. So in the second part we are doing the calculation of arithmetic mean. For that we are making the table with columns headed as intervals M, F, small f, and the next column is M minus 45 by 10, and the last column is of FD, F times D. From the table we have collected the following information, that is A equals to 45, sigma FD is equal to 20, N equals to 229, and small c is equal to 10. Now we'll apply the formula, and the formula is x bar equals to A plus sigma FD by N into I, small I. So that is equal to 45 plus 20 by 229 into 10, which is equal to 45.873. When the class intervals are unequal, the frequencies need not be adjusted to make the class interval equal, and same formula for interpolation can be applied as discussed above. For this again we'll see an example, and that is example number 6. In this it says that compute the median from the following data given in the table as shown, which has marks and frequency as the two columns given in the question. We'll see the solution. In the solution we are doing the calculation of median. For that we are making a table of marks, frequency and cumulative frequency again. Now according to the formula, median is equal to x bar, that is equal to size of n by 2th item, so that is equal to 60 by 2, that is equal to 30th item. Now median lies in the class 30 to 60. Median, again the formula will apply, that is interpolation formula. Median equals to x bar equals to L plus n by 2 minus CF divided by F into C. So we're putting the values here and we get 30 plus 30 minus 20 by 30 into 30. So that is equal to 40. Again, for this we'll see an example, and this is example number 7. In the example it said compute the median from the following data given in the table, and the table shows 2 columns, marks and frequency. In the solution we'll see the calculation of median. For that, again, we are making a table of marks, frequency and cumulative frequency as shown, and we are applying the formula median equals to x bar, that is equal to size of n by 2th item, which is equal to 60 by 2, that is equal to 30th item. Now median lies in the class 30 to 60 again. So median here, the formula for median, interpolation formula, that is equal to x bar equals to L plus n by 2 minus Cf divided by f times C. So let's put the values and we get 30 plus 30 minus 20 divided by 30 times 30, which is giving us 40. Let's discuss merits first. The first one, it is specially used in case of open-end classes, since only the position and not the values of item must be known. Second, it is not influenced by the magnitude of extreme deviation from it. For example, the median of 10, 20, 30, 40 and 150 would be 30, whereas the mean will be 50. Hence, very often when extreme values are present in a set of observations, the median is more satisfactory measure of the central tendency than the mean. Third merit, in markedly skewed distribution such as income distribution or price distribution, where the arithmetic mean would be distorted by extreme values, the median is especially useful. Fourth advantage, it is most appropriate average in dealing with qualitative data, that is, where ranks are given or there are other types of items that are not counted or measured but are scored. Fifth advantage, the value of median can be determined graphically, whereas the value of mean cannot be graphically ascertained. Now we'll see some of the demerits as well. The first one, for calculating median, it is necessary to arrange the data. Other averages do not need any kind of enrichment. Second point, since it is a positional average, its value is not determined by each and every observation. Third point, it is not capable of algebraic treatment. Fourth disadvantage, the value of median is affected more by sampling fluctuations as compared to the value of arithmetic mean. Fifth one, since the median ignores the importance of extreme items, it is not useful in those cases where large weights are to be given to the extreme items. Sixth one, it is erratic if number of items is small. So that brings us to discuss the next topic, which is about the positional averages, and the first one comes here is quartiles. We have done above the median is the value which divides the data into 2 equal halves. The quartiles are the values which divide the data into 4 equal parts now. These values are known as the first, second, third quartiles, and usually they are denoted as Q1, Q2 and Q3 respectively. Procedure for computing quartiles, decile, percentiles, etc. is the same as for the median. While computing these values in individual and discrete series, we add 1 to n, whereas in continuous series we do not add 1. Thus, Q1 is equal to size of n plus 1 by 4th item in individual series and discrete series. Q1 is going to be size of n by 4th item in case of continuous series. Similarly, Q2 is going to be the size of 2 times n plus 1 by 4th item in individual series and discrete series, whereas Q2 is equal to size of 2n by 4th item in case of continuous series. Similarly, Q3 is the size of 3 times n plus 1 by 4th item in case of individual series and discrete series, whereas Q3 is equal to size of 3 times n by 4th item in case of continuous series. Similarly, we'll see for deciles. Let's see for D4. So D4 is nothing but the size of 4 times n plus 1 by 10th item in individual series and discrete series, whereas D4 is equal to size of 4 times n by 10th item in case of continuous series. Similarly, in the case of percentiles, like for example for P60, if you want to calculate, it's going to be the size of 60 times n plus 1 by 100th item in the individual series and discrete series, whereas P60 is going to be the size of 60 times n by 100th item in case of continuous series. So we'll see example for this, and example number 8. Find out the value of upper and lower quartiles. Alright, so upper and lower quartile means Q1 and Q3, D2, P90 and P5 from the following table of data. So table, we are given a table of marks and number of students. So we can have a look over the table. Let's see the solution for this now. We'll make another table, and the table will contain of marks, number of students and cumulative frequency, that is CF column as shown. Now lower quartile, or it is also called as Q1. So this is nothing but this is the size of n by 4th item. So that is size of 80 by 4, that is equal to 20th item, because n is equal to 80. Now Q1, it lies in the class 20 to 40. So Q1 to Q1, now we are applying the interpolation formula, and that is L plus n by 4 minus CF divided by F into C. So that is equal to Q1 equals to 20 plus 20 minus 18 by 22 into 20. So that is equal to 21.82. Now let's see how we are going to calculate upper quartile, which is Q3. So that is equal to the size of 3 times n by 4th item. So that is equal to size of 3 times 80 by 4, which is equal to 68th item. So that shows that Q3 lies in the class 40 to 60. Again, we will apply the interpolation formula and we will calculate Q3. So Q3 is equal to L plus 3n by 4 minus CF divided by F into C. So Q3 is equal to 40 plus 60 minus 40 divided by 25 into 20. So after calculating it, we get a figure of 56. Similarly, we'll calculate D2, and D2 is a size of 2 times n by 10th item, that is equal to size of 2 times 80 by 10, which is equal to 16th item. So D2 lies in the class 10 to 20. Now D2 will be L plus 2n by 10 minus CF divided by F into C. So D2 is equal to 10 plus 16 minus 18 divided by 10 into 10, which is equal to 18. Let's do the calculation for P90. P90 is the size of 90 times n by 100 item, that is equal to size of 90 times 80 divided by 100, which is equal to 72th item. So P90 lies in the class 60 to 80. So P90, let's apply the interpolation formula, and it is L plus 90 n by 100 minus CF divided by F into C. So P90 is equal to 60 plus 72 minus 65 divided by 10 into 20. So the whole thing is equal to 74. Now similarly for P5, it is the size of 5 times n by 100 items. So that's a size of 5 times 80 by 100, that is equal to 4th item. Now P5 lies in the class 0 to 10. P5 will be equal to L plus 5n by 100 minus CF divided by F into C. So P5 is equal to 0 plus 4 minus 0 divided by 8 into 10, which is equal to 5. A third type of central value or center for the distribution is the value of the greatest frequencies, or more precisely of greatest frequency density. Graphically, it is the value of the x-axis below the peak or highest point of the frequency curve. This average is called the mode. In other words, it is the most frequently occurring number found in a set of numbers. The mode is found by collecting and organizing the data in order to count the frequency of each result. The result with the highest occurrence is the mode of the set. The mode is defined simply as that value in the data set which occurs most often, that is, has the highest frequency. For example, consider the figures below, which relates to the number of hours of overtime worked in a particular week by 15 laborers. So we have these 15 laborers and the hours are like 2, 5, 1, 5, 7, 5, 2, 8, 3, 5, 4, 2, 5, 4, 5. So looking at this data, we can see the mode is 5 because this value occurs more often than any other value in the data. So that's very simple in case of individual series. Now let's do the calculation of mode in case of discrete series. In this series, it can be determined just by inspection, that is, by looking to that value of the variable around which the items are most heavily concentrated. For example, example number 9, find the mode of the following data. So the data is given in this table. So table, it contains size of the item and the frequency. Now we'll see solution. The model size is obviously 6 as it is having the highest concentration of frequencies. We have known that in the above data set, mode was visible at a glance because the difference in the frequencies is very large. Right? Now this is the next case in the for the calculation of mode, which is in case of continuous series. So we have seen the calculation in case of individual series and discrete series. Now comes the continuous series. This is based on applying the simple proportion to the graphical method of solution. It may be shown that the following formula gives the position of the mode. So mode is equal to, in this case, Z, which is equal to L plus F minus F1 divided by 2F minus F1 minus F2 times C, where capital L is a lower limit of the model class, small c is the class interval, small f is the frequency, small f1 is the frequency of the group before the model class, f2 is the frequency of the group after the model class. We'll see an example for this. Find mode of the following data. So we have this data in the table of sales commission, which is given in rupees, in hundreds, and number of representatives. So for the solution, we are given that L is equal to 50, small c is equal to 5, f is 22, f1 is 19, and f2 is 13. Now we are simply substituting these values in the formula of mode and we are calculating mode. So mode is equal to, the formula we have is L plus f minus f1 by 2f minus f1 minus f2 times c, which is equal to 50 plus 22 minus 19 divided by 2 times 22 minus 19 minus 13 into 5. So that is equal to 50 plus 1.25, which is equal to rupees 51.25. Merits. It is simple to calculate and easy to understand. Second, it is not essential to know all the items in the series to compute mode, and extreme items have no effect on the mode. Third point, its values can be ascertained graphically as well as empirically. Since it is the most typical value, it's a most descriptive average. Let's see some of the demerits. The first one is the mode is ill-defined and indefinite. It lacks the important condition of an ideal average as it is not rigidly defined. Second, it is not based on all items and hence cannot rightly called representative. Third one, often it requires grouping, which is a time-consuming process. It is also seen that a mode is obtained which is actually non-existent in the series itself. Fourth one, no algebraic treatment is possible in mode. It is not a good measure of central tendency. So finally, we have come to the end here. Let's quickly summarize what we have learned today. We have got to know meaning of median, mode, and positional averages and have discussed about them with few examples. We have also determined the three methods of computing median, quartiles, deciles, percentiles, and mode. Also, we have included demerits and demerits of these averages in the script. So that brings us to the end of today's session. We are ending here with the second part of measures of central tendency, and we'll see you again discussing about our next topic on measures of dispersion. Have a nice time. Thank you and bye.